Okay, so as we transition to Fusion 360, I'm going to make a nameplate, and it's a pretty cool program. It does have a cloud version, but what I found out earlier today, the object that I made yesterday, I couldn't print today. So I downloaded Fusion 360. It's an Autodesk program, and most important thing about Autodesk is it's free for educators and students for a 1-year license. There's a trial period for 30 days, and sometime in that you should get your educational license. But they're pretty draconian about who can actually keep their educational license. So download it. 30 days, we're out of class, but go ahead and hook yourself up for an educational license too, if you can. All right, so we're going to make a basic nameplate. Very simple thing to 3D print. Very simple thing to design. Now, Fusion 360 is our parametric modeling software. Let's get rid of that. And what this means is you're going to create a sketch with a bunch of dimensions in one 2D plane, and you're going to extrude that into a third dimension plane. So up here, this is the sketch, and up here, this allows you to manipulate their direction. So if you click on it, you can manipulate. First, we're going to create the simple nameplate. Create a sketch, and we want to create it on the XY plane with Z coming out at us. Okay, so you might just notice X here is on the left and right, Y is on the up and down, and Z is coming out at us. And these are millimeters. I'm going to make a simple rectangle. I'm going to do a two axis rectangle or 2 vertex rectangle. Click there and drag, and we can make the rectangle whatever size we want. But one thing that's really neat is we can actually hit tab and go through these dimensions. So I'm going to hit tab. I'm going to make it 120 millimeters long, tab, and 40 millimeters high. Okay, so that is my basic rectangle. Now, right now, it's a 2-dimensional plane sitting on the XY plane, and it has no depth at all. To create depth, we can hit the letter Q on our keyboard or right-click and do a press pull. Okay, so what a press pull does is it gives it some depth. I can drag it up. You can see I'm making a rectangle, or drag it down below the plane if I want to. And there's lots of things we can do with this, but right now we're just going to make our nameplate, and we're going to make it 5 millimeters thick. Okay, so now it's a rectangle. If I hold my middle mouse button, I can drag it around the workspace, and if I hold down Shift and then middle mouse button, I can look around, and you can kind of see what's happening to the object, and you can see what's happening in the viewpoint here. We can also click on a plane, top, front, left, and so on, to look at like view on those areas, and we can hit the home button and it'll go to this angle here. This is the basic home configuration. All right, so now we're going to do what's called fillet. Fillet is rounding off corners. A lot of objects that we see in real life have rounded off corners. My keyboard has rounded off corners, so they're not sharp. So that's what filleting does. So we're going to fillet the top and the sides and the bottom. So this is the fillet tool. I'm going to click the fillet tool. Then I'm going to click the sides that I want to fillet. All right. Okay. Boom, boom, and did I get them all? I think I got them all. 1, 2, 3, 4. Yep, they're blue. And this is how big I'm going to fillet, the radius. My plate is only 5 millimeters high, so I'm only going to fillet 3 millimeters. If I did it 5, it would go down to the bottom. I don't want that. 3 is just fine. Okay, so we got our nameplate so far. Now we are going to 3D print this. And while we want it to look like this, when we 3D print it, you're going to get what's called the elephant's foot effect. Because when you 3D print something on a hot platter, on a hot 3D print plane, there's going to be a soft plastic, and every layer on top of that plastic is going to squish the one below it. That causes it to kind of stick out a little bit, kind of like the bottom of the Eiffel Tower kind of goes out to the sides. That's called the elephant's foot effect, and we want to reduce that as much as possible. Most slicers have a reduction to the elephant's foot effect, but we can also do it in our model. So I'm going to hold down Shift and then middle mouse button to flip it over, like so. I could also just click on bottom. And I'm going to fillet the edges of the bottom of the plate, because that's going to give it a little bit of wiggle room. So the squished out plastic can kind of squish out even further. So go fillet my edges, 1, 2, 3, and 4. And I'm going to fillet it only at 0.5 millimeters. So that's going to give it a little bit of a gap So when the plastic squishes, it'll be more or less flat. It also makes removing pieces off of the 3D print plane easier. Okay, so we got that. We're good so far. If we want, we can also fillet this corner edge right here. So I'll show you what that's going to look like. If we fillet that edge right there, this is 1 millimeter, it's going to give you a rounded edge like that. So you get the rounded edge instead of the straight edge. I think it looks pretty nice, but you can do straight edges if you want. Again, fillet. We're going to fillet that edge and that edge, rotate it around, and also fillet that edge up there. Again, 1 millimeter. Boom. So now you have these handy, soft corners. Pretty nice. All right, now we're going to put some text on it. So let's go flip it around. Let's actually flip it, let's go home. There we go. Now we're going to add some text. And the way this works is we need to create a new sketch on top of our box. So we're going to take this top plane of our plate, and make a new sketch. So create sketch, top plane. And now we're looking at this. We can put whatever we want on here. Here's some quick buttons. We can also go down to create and create text. There's my text. And in the newer versions of Fusion 360, you create a text box just like if you were in a browser, a word processor, like Word or Documents. Click. All right. And there's our sample text. I'm going to put my name. There we are. And we can change the size if we want. We can align it center, align it middle. Let's go ahead and try for 14 millimeters. There we go. We can make it bold. We can make it italic. And we can change the font. So let's find a fun font. Britannica? Oh, no, not that one. Broadway? Maybe. All right. And I like Calibri. This is my favorite. All right, so there we go. And we can make it bigger if you want. Let's try 15. All right, so 15 millimeters. And now we got our text on here. Now, right now, it's a single two-dimensional plane on a two-dimensional plane. So we're going to extrude the text. So hit Q, and it's like, you want to extrude that? I do. I want to extrude that. And I click on my text, hit Q and click on my text, and now I can extrude my text out. I can do what's called making it proud, making it go above something. Okay, so there we go. I can also dig it in. If I dig it in, it's a cut. So I can go cut it, or you know what? I'm actually going to cut it so I can show you another feature. Okay, so now I have embossed my text into the object. Okay. If I ever want to change a feature, this is kind of neat. This down here is the workflow. I say, you know what? I don't really want to emboss it. I want to have it come up. So I'm going to right click and edit feature, and it jumps right back to whatever I was just doing, or whatever I was doing in that feature. And now instead of mine's 2 millimeters, I want to give it 2 millimeters up. And it says, I want to join it. So instead of cutting it into the object, I want to join it above the object. And there we go. Now we have text that is proud. So when we print it, the plate will be one color and the text will be another. Kind of neat so far. Okay, next. Now that that's done, let's go ahead and take a look at this. Looks pretty good. And now we're going to add some holes that we can put screws or pins in. So this is the hole tool right here. Click the hole tool. And it says, where do you want to put the holes? Well, I can put it anywhere I want. These are all the places I can put a hole. So you can see the little circles and stuff. What I want to do is I want to put multiple holes on these little axes. So if I go here, it's like, hey, you're going to put a hole? I am. But I want to put it right there. In fact, I guess it's not going to do the multiple for me. Go back to single hole. And see the little vertex there? I want to click it right there on the corner. Now obviously that's going to make a huge hole. I don't want to make a huge hole. I want the hole to be only 2 millimeters in diameter, just like that. And I can basically distance, I can say go through everything, or I can give it a depth. Right now the depth is 10 millimeters, which is way more than I need. I only really need 5 millimeters. If I gave it 4 millimeters, then it would actually only go part way through the box. And I could click OK. So now I have a hole where I can put a screw or a bolt or a nail or something. Let's do it again. Now it should allow me to do multiples, but I don't know why it wasn't. So I'll try it again. This is multiple holes. Multiple holes should have allowed me to, a little hot spot came up. Well, I guess it's not going to. All right, well. Okay, so put it on the vertex again, wait for the little dot to pop up, and right, there we go, right there. Same thing. It remembers the last setting, which was 2 millimeters and 5 millimeters deep. Click OK, and let's come over here and do it again. Hole. Where do you want to make the hole? Right there. I don't know why it keeps popping up and then disappearing again. That's really strange. But we have to be patient with the program. Some of us are on faster computers, some of us are on slower computers. And come on, go up again. There we go. Click there, and there's my hole. Okay, so now we got 3 holes, and my 4 holes. My 4 holes are right at the corners, so there's symmetry. And if I put some nails or some screws in there, the screws are going to sit on top. If I want the screws to go down into the hole, what I'm going to do is I'm going to change the hole so it's thicker on the very top to give it space for the screw head. Okay, so I'm going to go to my feature here, right click, edit feature, and I'm going to change the shape of the hole. So you can see the shapes of the holes. This is a typical cylindrical hole. This is a counterbore that gives me a hole for basically a rectangular shape or a round screw. And this is one, countersink gives me one for a beveled screw. So I'm going to do one for a beveled screw. And my beveled screw diagram is right here. So the screw depth, the diameter is going to be 2 millimeters, but I'm going to make the top actually a little bit bigger. I'm going to make it 3 millimeters. Okay. And when I click that, now I have a screw that has a bevel where the screw head can actually sit on top. I can do the same thing with this bottom screw, only this one, I'm going to edit feature, and I'm going to do a counterbore, and I'm going to give it its 3 millimeters again. So the top's going to be 3 millimeters, and I'm going to give it a whole 2 millimeters of depth for the screw. You can see what this is going to look like. So now you can see the screw there. It's got a full 2 millimeters of space for the screw to go down below the nameplate. Okay, and I'm going to set the other one like that too. I'm going to edit feature. I'm going to do a counterbore, 2 millimeters across. Well, I want the top to be 3 millimeters across, and I want it to be 2 millimeters in depth. There we go. All right, so there we are. So the counterbore will have plenty of room for the screw. I'll scroll over, and again, for reasons that I do not know, it's not allowing me to do this all at once. Usually you can drop a bunch of holes, and like this button up here, drop a bunch of holes, and then it will automatically change all the holes. I don't know why it wasn't allowing me to do that, but I have left a note in the forums for something that's happening with the online version. So maybe they just made an update and there's errors. So counterbore, 3 millimeters, and we're gonna make this 2 millimeters. And we are done. We are done with our plate. Okay, so now I have a plate and it's got some text that's raised up. Now we're gonna 3D print it. So we're gonna go to save it. We're gonna save this as plate 2, because I made plate 1 yesterday. Plate 2. And we're going to go to File up here and 3D Print. This is going to cause it to be created as an STL, which is what we want. Now, if we click this button where it says Send to Print Utility, we can actually install a print utility. We don't want that. What we want is to unclick that, which is going to give us a file. We just want a standard STL file. We don't want to export it anywhere special. We just want to be able to use it on our own. Okay. And refinement. Basically, this is how many triangles you get. The higher your refinement, the better. Medium usually works fine. And click OK. Okay, body 1. Yep, this is we're gonna call this plate 1. And we are done. Okay, now we're gonna 3D print it. So I'm gonna minimize this, and pause. Okay, so I unpaused, and we are now at the GitHub for Prusa Slicer. The current version is 2.3.1. And this is, in my opinion, the best slicer. It's based on a program called Slicer PE, and then Prusa got a hold of it and made some minor changes. But most of you are going to be using Prusa Slicer Win64, so I'm going to click that. It's going to download it super fast, and then I'm going to put it into a directory. It doesn't actually have to install. It just needs to be in a directory, which is kind of slick. So I'm going to open my file, and I'm going to put it into someplace in Windows. There it's on my C drive. Here's Prusa Slicer. This does not take very long. So the 3D printers that we use are Ender 3s. They've been heavily modified, but they're Ender 3s. And I don't know why this is taking so long. Doesn't usually take this long, which is kind of strange, but it's only about like a 15 megabyte file, but whatever. Well, it's almost done, and it is done. Okay, so here we are. Right click. So we want Prusa Slicer. I'm just going to put that on the desktop and make a shortcut. And the first time you run Prusa Slicer, it doesn't know what program you're running. So your slicer actually needs to know what your hardware is. Because all slicer software does is it takes the STL and it slices it into little wafers that the 3D printer can then print. But you need to tell the 3D printer what machine you have. So I'm going to come down to other vendors, and we have a Creality. Next, we have a Creality Ender 3 with a 0.4 millimeter nozzle. It's very popular, which is why the first one on there. And next, and do I want any configurations? Nope, and I can finish. So now my configuration's up here, ultra detailed. No, we want generic PLA, polylactic acid, and we're going to use our Ender 3 configuration. And the Ender 3 configuration, it's going to look like this. This is the base of the Ender 3. Okay. And we have a whole bunch of print options that we can play with, but that's a video for another time. Most important thing is to know that your bed temperature and your nozzle temperatures, this is a really good number. Again, this is a curated profile by members. They found 210 on the nozzle, the hot end, and 60 on the bed works pretty well, and I found that to be the case too. Now we're going to bring in our file. So we can click here if we want, or we can drag and drop. Downloads plate 1. I'm going to drop it right there, and it's going to read the dimensions and say, all right, you made this 120 millimeters by 40 millimeters by 7 millimeters high. 5 for the plate, 2 for the text. Pretty simple, right? Okay. So now we're going to hit slice. We can change the dimensions if we want up here, but we're not going to. And this is the infill. This is how thick it's going to be. A high infill means there's going to be a lot of plastic inside. A low infill means there's going to be lots of gaps. So just for purposes of showing what that means, I can hit 10% and slice. All right, so very quickly it sliced because it's a very simple object. And this is how the slicer works. This is the individual layers. The slicer is telling me that it's going to take 43 layers, and the numbers up here are in millimeters. And then you can see what's going to go on in each layer. If I go down to the very first layer, I can actually pull this back, and it shows you what the print head is doing. It's going to draw a box, then it's going to draw the circles, and it's going to draw the circle, or basically start the plate, and around it goes. And it grows and goes and goes and finishes the first layer. And the second layer, third layer, fourth layer, fifth layer, sixth layer. And you can see this is called infill. This the gaps here, it's going to make a grid and put everything on top of it, and everything else is going to be hollow. So the higher your infill, the less hollow you're going to be. And the lower the infill, the more space you'll have. Okay. And we want to go through the end. There's the bevel, and there's the text. So we want to make this a different color. So what we want to do is we want to go down until the text just starts and click the plus. This is going to tell us, this is going to tell the 3D printer to stop printing and tell us to put in new filament. Then everything above it is going to be a different color. Okay. You can change the colors in here, by the way. You can actually say, no, I wanted to see what it's actually going to look like. So I'm going to click on it and make it a different color, but yeah, I'm not going to worry about that now. All right, so go up. So it's going to print, print, print. This is the back side, and the very first layer after we switch is going to be the text. And it's going to print, 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 and it's done. Okay, there you go. Now, if you want it to be smooth, there's a cool feature called ironing. You can turn on in filament settings, but I'm not going to read about it right now. So once it's done, we basically said, I'm going to make this a certain color. Then I'm going to tell the printer to stop. I'll put a new filament in, and it'll finish with the remaining color, and you slice. Now, at 0.16 optimal, which I very much like, it's going to take 1 hour and 52 minutes, and it's going to use 16 grams. Not bad. Okay, so that's how you make your nameplate. And hopefully this was helpful. You can get into the Autodesk and start making your video or start making your plate. All right, have a great day. Goodbye.